in a group, bro. Safia did say.
Logisim I group. You download it. I have a MacBook in a dog.
Oh, yes, Saf. Yo, then you really there sit down so long?
Yo,
Adel, you have a link already? Yeah.
yo.
Every man, every man
Oh,
download Logisim.
that's in the file too.
Logisim.
Pusi ang text mo kanina mo ka si business. So good.
It's in the file. Sure, you're not there.
Morning.
Quad,
Hi. Hi.
Here, you know,
Hi.
man. You know, man, to here.
No, yeah.
Yeah, here.
No.
Here.
Just eating.
Where you want to go booking?
Yo, I know you say, me short up with today, me that go study for microcontrollers, and me say we not do unit 6.
Kaya na ako may exam, brother.
You better pray say not coming now multiple choice.
So, unit 6.
Unit 6, hold on.
Again, apologies.
Application specific integrated system, intro to FPGA, assembly language, intro to VHDL.
But anything I'm gonna teach you.
The thing is, bro, you're gonna need that for next semester. That's why I said
When next
VHDL in a semester.
when next semester come worry about that, brother. Now worry
You
about
see, and that we did do in Pinto. Alright. You see, no man can have a wire circuit, but it's alright.
You can't wire circuit. We good.
Just make sure you don't catch a fire here.
You think I'm already
bro,
talking?
this them are more important story about, brother.
Yo, tell me when you're ready, dog. Because,
Really right now,
Join
Mikey.
time for my laptop.
Start right now, man. Not one night. Start right now, man. Not one night. I love money.
yo,
Boy, wait until
me not love man neither, me we live this ass.
Hold on. Let just see my install still.
Yo, make it go and install me. I explain in the meantime.
Alright, be ready.
Alright.
You done? Go. Hold on. Which one did you on? What?
Oh,
Hey, that Chad?
Man, I'm distracted easily.
yeah.
and then I go.
She's taken, guys. Don't worry.
How did I always talk about the matic?
Chad,
I reckon what's the like? I reckon what's the like there?
Chad, when is my birthday party, dog? Party I keep. It's a birthday party I keep. They didn't invite my birthday party, brother. I'm your friend.
You know what was a birthday party? Me not even there that year, bro.
There's a big cake by your kind of regular, brother.
I'll reach up my head, my ear. You know, they may think we're gone.
Big birthday party I keep, brother.
Actually, we're hungry, but they didn't invite me.
Yeah, man, Black Forest cake and the work, and we're man him something down there and curry goat. And they didn't invite me.
Actually, we're hungry, belly, man.
Yeah, man.
After exam, I go over the beach. Over Bob Marley.
And boy in a rate way.
Yeah, big birthday party down there. And birthday party. You see?
Freaking ain't him. Freaking ain't him.
You see that keep party
As
tonight,
someone say, yo. As someone say, we dog married Mackie, me ain't not get invited, you know.
Yeah, man, the same way, man.
You'll be bring her back to brother. You'll be. If man not even say nothing, I say, yo, bring her back to brother.
Yeah, bring her back to our mom.
Go.
Mike,
You
you're
reach
there.
laptop, Chad?
Huh?
You reach my laptop now?
Yeah, man, let us see my rector. Let us see him up. Yo, man, they must send it.
Might see the back of
Let
time.
us see him find on that group, eh?
Alright.
Can you hear me?
Yeah, bro.
Yeah, what? Just extra key on Sunday. What to do for the first? Salaman, I don't think what to do. It's me, fella. It's in the absence.
Yo, already. So the first thing say we need is we're gonna need the 4-bit predefined password, which are the constant name, right? So you're gonna put a constant in your circuit and you're gonna change the number according to where you want it. According to where you want it to be. So if you want the password to be 1111, you're gonna change this to 1111. So you just click on them and type in 1 or 0 depending on where you want. So like that one, if you want it to be 0, you want it to be yeah, that's it, yeah. You can come and change it to steps. So you can change the value to 0 times 0, which is oh yeah, 0 times 0, which is 0, or 0 times 1, which is 1. Alright?
Wait about.
Now talk about find password. Where you find them? Alright, I'm gonna show you where you
Mike
find.
here is exclusive R.
Yeah,
You
exclusive
can't use
or
R. You can't use NOR gate them alone. R
no,
gate alone.
no, because of the type of input you want. The type of input and output you want.
So how
Because
data and connect it to
look.
or not gate.
Alright, look now. You want it to be a case where when the two of them correct, them give you a high, right? But at some cases you have 0 and 0, but you want 0 and 0 to give you a high.
Oh,
And you
brother, but the way how we and Lemar did that do it, it work. Only thing what did
which
that give me problem I reset like after 83 attempt you can't do no else, brother. I clock alone did that give you problem.
cause
The
Lemar put too
content.
much stuff in a circuit, brother. Look here. Alright, look. Follow this, follow this. See reset button here, right?
Yeah.
Look where reset connected. The reset connected at the counter, the reset connected on my flip flop. So what I do is me connect the flip flop to keep the value at 1 when the password correct, which is 1010. Notice that this I give me a 1 and 1 I come here so. But it now go change the value if you send it towards the lock. Where lock there? I will like that. Oh, yeah. It now go carry this value to the lock until you press the enter button, which is the attempt. You see change now? And the lock go green. And using that same signal from this, use it as a lockout mechanism. So if the password correct, then it now go allow you to enter, yeah. In it now go allow you to enter any more password. So the counter now go
Alright
go
now,
up as
alright now I have to go connect back everything and delete some
alright.
things.
Well,
I
look
forgot
on
to patch
this.
my script.
So what me do is Chad, me use tunnel so the circuit them look cleaner, you see me? But
Lemar teacher tunnel.
no, me just see him do it. No, him never teach me. Me just see it on him screen and me say, boom, but why me never do that?
We even know what I'm talking about, but all right.
Alright, so tunnels. So it's basically like you do a wireless connection. So instead of physically having to come here and draw one wire come way up here, so you just connect it to one tunnel and then you can put the same name of the tunnel somewhere else and it carry the signal go over there.
Oh,
But
so
you can
I like on connector then basically.
yeah, so look. In this case, so the password them, right? So I
Mm.
have password 1, password bit 1, right? Which is this. I have the constant bit 1, which is this. So part PT1 is connected to here, so which is the input to the checking mechanism, which would I check to see if the password match with the constant.
Mm-hmm.
Right. And that now go through the XNOR gate and give me an output which is password check 1. Password check 1 goes into a 4-bit AND gate. Right. So then we have a correct password tunnel, which is this. But we can put that anywhere now when we want to use that signal there. So in this case, me use this in the flip flop. So as me say, the flip flop can be used to hold the value that was entered until another change is made. So in this case, I have a correct password that go in the flip flop. But it now go change until me make a change, which would have if you press the enter button. So as you see, the lock still lock, even though the correct password enter. But you not press the button physically yet. Say
Benjamin,
okay.
like
Eh?
no, no, look at it.
Yeah. So when we press enter, it change and send the high signal to the on or off signal. And that's go into an AND gate to the lock and gear this. And then now, let me just show you how it works. I think me this in a video still, but if you put in the wrong password 3 times, so 1, 2, 3, it send a lockout signal. As you can see, the lockout down red and the lock still red. You notice it count as a 3 and you can't make no more attempt no matter how you press. It now go through because as you can see, you have a negated lockout here to an AND gate you're supposed to go to the lock, right? So if me I press enter, you now have no signal that go towards the lock. Because the AND gate, because one already has 0, you know. Yeah, so no matter how you have one over that side, it will show 0. Right. So I just really and alright, wireless connection now. So you go in a wiring. Yeah, go say, alright, let me just create a new one so you can see that. Right. Alright. So first thing you go do, you go take out go in a wiring and you go take out your constant. You place a constant and you can change the direction in which it face if you want. Yeah. So if first constant I go be 1, I go put on next constant and say 0. Yes. And I say 0. No, you can click on here and enter it. Yeah. So you can click here so and press 1 or 0. Yeah. So see them I press 1 and it change, I press 0. But because it's a 1 bit, it's a 1 bit constant, you can only have 1 or 0. Because if me try type into it now go through. So let's say my password are 11, right? I mean, I don't know if you know I'm gonna put in the full 4. Alright. So me I go put in one tunnel now to collect that signal here from all 4 of the boxes, the constants. So just like that. And then you put in one name. So you can say constant 1. So that'll be constant 1. I will copy this now and create one tunnel for constant 2. Right? So if me want instead of physically having to draw a wire to go all the way over this in one gate. So let's say I put an AND gate over here. So and instead of physically having to draw a wire to come here, so all me have to do is instead of doing this, I just draw one tunnel. So as you can see, we have C1, which is first constant, and we have C2, which is second constant. So this help you with organization. Alright. So now the same tunnel way you use up here, so you have to use back the same name, or else it now go correct. So
You know, rotate that now. Oh.
so then this going to AND gate, this going to AND gate. So this means this a constant and this a constant a match, because as you can see, you get one green light I go through, which means you have a high signal. So let's say more and take the high signal you know and carry it somewhere else. You just put one tunnel there, so name the tunnel whatever, password match, and then you copy this a tunnel here, you put it where you want it to go. If you want this to turn on one light, you go so now and you get one LED promoter input output, and you put it there so and connect it to this. Right, and then in our properties down here, so you gotta change the color of the LED when it on and when it off. So green on, and you can set red to off. Yeah. So let's say if me dey change the bit to 1 0, see it gone red because the two of them not much.
Yeah, cause for hand gate, you know, so everything have to be one.
Right. And if me change the two of them to 0, this would have to be one thing they get forget. But anyways, you get the basic
On
concept.
invert. Mm.
That'll be one non gate.
Yeah. So basic operation is that Sarah want if you create one. The first part of it, himself we create one 4-bit password system using the switch them, which should be them something that I'm gonna show you next. So you have your four constants them here, so I'm gonna say copy this and create constant 2, constant 3, constant 4. Alright. Let me show you what happen now when you have two tunnel with the same name. So this is an input from the constant. And this is an input from the constant here. So you have two different inputs coming from somewhere. You're gonna have an issue, that's why it's show red. So I have to change the name yourself. You say, okay, this is one here constant
C3.
3,
Next one C4.
right? And that one here gonna be C4. But you can't have two input into one tunnel. Right. So let's say the whole password are 1111. So
Mikey, what you know?
yeah,
Things are binary, dog. You know what I say? Oh?
what you say?
Things are binary, right? So I get values. Like, you know, say if I one did by itself, you know, say that be one. That 2 to the power 0 1. And then
Mike,
forget the entire password.
Mm-hmm.
It's
yo.
like, oh,
So I mean, can I assign the password to it too?
Eh?
I mean, assign the password to it to the 4-bit
Yeah,
password.
you assign. See the constant them are the password. I go put
yeah,
in the button them now if you enter the password. To see if where you enter match. That
All right.
we're gonna know.
So what's in a so all right. So in your case now, where you use the AND gate. Let's say me put in like a 1001 as a password. You see me? The AND gate
Mm-hmm.
could use this.
Yeah man, and gate no, not here so but you still are gonna use and gate to put all four of them together.
Of a multiply.
Right. You said-
Oh,
So so
and then we can use an inverter
look back
to
here
put
so.
the signal through.
Look back here so now. So what you see me do is I have the AND gate for match. Alright. First thing, I have the password where you enter and I have the constant that is predefined.
Mm.
Mikey.
Right. So this way you enter have to match the constant. So when the two of them match, me use a XNOR gate because XNOR give you a 1 when the value is 1 and 1 or 0 and 0.
Mikey.
So
Mm.
mhm. And then me use that
Yo,
as my output. Yo,
like how you have your own, so brother, you need that for the so up at the top part, the input from the constant and the
yeah,
pin number,
yeah.
whenever just connect it straight. And then you use the tunnel on
Yeah,
the base part.
but it just me did I go put them here further from where them are there. Like me want them to look like specific circuit.
So you just draw a line to it then. I see him thing it will be.
No man,
Look
let me
at
show you what I did off
aesthetic.
chat.
So yeah,
Look,
dog.
look. Let me show
Look
you
at
how it
aesthetic.
is set up. Look, when it's set up like this, me just put them this off the show now. So you see constant never the same place where password there.
Yeah, but may I say, you can just connect it constant and the pin number,
Yeah,
T-gate
you
itself,
can. You
and
can.
then use the tunnel.
Instead I use the tunnel here so we can just put the password there on the constant. Yeah, you can. But me I use tunnel because it just make it look neater. Mm.
You can use the tunnel like output.
Yeah, yeah. Because everybody are gonna do something different, you know. 'Cause you can have the same.
Aesthetic.
So yeah, yeah dog. So back to this now. So I have four constants here, so I'm gonna put in four pins. So pin one, you double click on it to name them here. So that a password one. I'm gonna enter pin two. Yeah, so I can just copy and paste so pin three. Eh? Um four. Yeah. So if you want, as I said, me put them side of them one another for fullness sake. Yeah. Alright. So now that you have that signal here, honestly, no one just go straight in it. So now I have to do that then. So now I'm gonna put in my gates them. I'm gonna put in X NOR gates.
So question.
Yeah.
After be expression get them after
Yeah, because only an X NOR gate gives you the output of one when the value is 0 and 1 and 1. Yeah. So unless you're gonna use one XOR gate and then use a NOT gate, I same thing. It's just that this make it easier because I just one gate I use.
Yeah, it's like a shortcut, short away, isn't it?
yeah, but
Yeah.
I'm gonna pre is that maybe no one like all of like see the same like structure.
Eh, Yo, anything will work for you, you know, dog. If it works, yeah. So you can use a XOR gate, and use a NOT gate with it. No problem. From it work. But I just owe me do mine. Lemar go do for him different. Everybody I go do for them some other way. I just forget the concept. You see me? Alright, so leaving from this now, which is the gate where I go check to see if your password correct. You go in our 4-bit AND gate. Make sure say all the passwords match. So you know want me use a tunnel yes or just go directly because it can. Alright. So you click on your AND gate and go in a properties and change it to a 4 input AND gate. So right, because I'm naturally two. Alright. And then from this now, these are basically what you want overall. This is your circuit. So you have one, 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 lock up. These are basically it in an deal. Eh? It's just that the reset mechanism and the lockout mechanism is what make it even more complicated. Because these are basically the circuit. That's all it do. It's just that what you want is that before it get to the lock signal now, if you say okay, open or not, you want a button where physically I go tell the user to press enter if you see the amount of tries where the user make. And then you want the reset mechanism to reset everything back to zero. And then you want a lockout mechanism if the person enter three incorrect password. So yeah, so these are your lock circuit basically. But instead of going directly to the lock, me I go move the lock and we are go put in with different mechanism now. So for this now, me did use one tunnel. We say alright, password correct. I go write it out so that no mix up. Oh yeah, you can't use space by the way.
At PC.
Me know, but me want to type it out so everybody understand. So me will use the shortcut then. Alright. So we have a correct password this up. The first thing I want to happen is that let me double check and make sure I'm not saying a foolishness. CPT are going to flip flop. We hold the value. You don't have to do this, but it better you do this. Alright. So I'm gonna drop one flip flop. Because what gonna happen is that without the flip flop, the moment you put in the password, it will go change your song. And you want it to stay at that value.
Which flip flop you use?
I want flip regular flip flop man. You have the
Yeah, I see four different flip flop right there, so yeah, tell
oh
me
no
regular flip
the
flop.
a
You know
D
what flip flop?
alright, well I know D are your regular flip flop, you see me? The regular flip flop is a D flip flop. So the first thing I gonna do is I gonna create one button, the attempts. So in my case, really and truly you have to understand the output logic where you want before you can do all of this. You have to create your own logic table. That make it easier for you. Because you know where you want one and you know where you want a zero. So we need a flip flop and we need a counter. Alright. Alright. That version of logisim is logisim evolution. Means you have some more advanced tools in there. This is an advanced counter. So all me do I change it from logisim evolution version to classic logisim, which is this. Yeah. Yeah. So for the flip flop now, me I go say correct password. I go into this section, Right. I want it for sure.
Which section?
Hold on. May I click on it for show you which part? Hold on. No, I know that tonight have a specific explanation for each ask. You see like how that come up? Everything have them specific explanation, but me don't know why that not come up. So this is a reset pin. You reset the flip flop. This are your complement. So if you have a one going, you get a zero come out. If you have a zero going, you get a one come out. Also. So if you want the negatives output, then you can take it from yourself. If you want the positive, you take it from yourself. So in this case, I'm gonna put the correct password tunnel.
So wait, the DFE data data input, right?
Yeah.
All right, cool.
So this is your input. And then you want something where I go update the flip flop. So only when that change, then this a value we updating on the flip flop. So you want an input signal. Let's say you can put a button in this case. So this would be like your enter button. So this would check to see if you wrong thing me do I pin that, sorry. I go for a button. So you take a button and let's say you want to name this enter and connect this there. So only when this press, then the password will go through. See turn on one here, so alright. So now this can even go straight to your lock, you know. So this would have stopped the password from change instantly before the user actually press the enter button. So let's say, as you can see, initially the circuit would have been zero because everything locked, right? So no put in the correct password and that not go through only unless the user press the enter button, then it will update. But because the correct password still has send a zero signal, we have a zero here. So I go correct all of the password them 1111. And you notice the correct password go green. But the flip flop not go change and update the password until the user press the enter button, which is this. Alright. So this enter button here, you can move it up here so that the user have access to it. Because let's say you have a specific section where you want to can touch or whatever. This is recited there behind the scenes. So you have your four pin them here, so your four pin them where them can change the values, and you have the enter button up there. So
Oh, the reason why I did the wiring because you know say turn on from when you turn off.
yeah,
That's why I hide them. Ah.
yeah. All right. So yeah, it gonna look weird when you are doing wiring like this. Because if me that do wiring them without a tunnel, you'd have to put this here so. We get correct password. All right. You know what me do it without the tunnel them, so I see
No
it
man,
directly.
run them.
All right. Let's make sure. All right. So then now your counter. So me I go disconnect the lock from here. So the counter now you want a signal from enter. So every time the user press the enter button, then the counter increases. See me? Yeah, you get what I'm saying?
Yeah.
All right.
So
So
you connect the enter button to
right.
the counter.
So instead of doing this, we use one tunnel here so now. If you say all right, the enter signal I go come from up here so. And we will connect one tunnel to this. Connect one tunnel
never see you.
And say attempt. So this will go register the amount of attempts of the person make.
Hey, bro, this look tough, dog.
Which came out.
¿Qué pasó? ¿Qué pasó?
Can't bet you be
¿Cómo estaba?
Eh? Yeah, for the counter, so you connect it to the enable, which I go allow the counter to either increase or decrease depending on when the value change. And then now you want a button for reset. So let me show you how the attempts work now first. So if you press the enter button one time, wait, hold on, double check something. Enter go in a okay, a clock if you connect. So you connect this to clock. The clock will update when you press. So you press this one time, you see counter go up by one. You press this two time, counter go up again. You press it three time, counter go up to three. See that gone up to 4, 5, 6, 7, 8. So now you have to put a limit on the counter to say what to do when it gets to a certain value. So you click on your counter and you can change the maximum amount of
The
bits you
mic, hold
use.
on, them. We support the mic, but the whole counterpart, we support it.
Alright, so
So,
your
really,
counter,
right?
you connect your enter button to your counter so you can check the amount of attempts that the user make. Because the password only go update when the user press the enter button, you know. You see me? You get that, Barry?
I mean, like, as in, like, the counter thing, where it come from?
Counter come out of arithmetic or memory. Memory, yeah.
All right, one.
Alright. So you connect your enter button to your clock trigger. So you need to change the properties of your counter now. We say, alright, maximum value of the counter gonna be 3. So in this case, you have 8-bit counter. You don't need a 8-bit counter, you're gonna say like 4. Or you can even say a 3-bit counter or 2-bit. Yeah.
But why
Because
not,
why difference? Alright.
why not put a 2-bit counter?
Two to
As in
the
a
two.
2-bit.
Alright. 2 to the 1 is two different values, right? 2 to the 1
Mm-hmm.
give 2, right? Means you can only have two states, 0 or 1. 2 to the
Yeah.
2 gives you 4. Means you can have 0,
Oh,
1, 2, 3.
I know
Yeah,
one easy one state, all one input.
right.
Cool.
No. As in like the amount where the counter can count, 2
Yeah.
to the 2 gives me 4 values. Meaning it says 0, 1, 2, 3. My maximum value is 3. So if me try to enter 4 as the maximum value, it will go change. It not allow you. Unless you change it to like a 3-bit counter. So you see the maximum with 3 is 7 because at 8 values it can record 0, 1, 2, 3, 4, 5, 6, 7.
Yeah. 2 to the power
Right.
3. 2 to the power 3 and 8.
Right.
I will put
But
for the
because you record 0, that count as 1 too. So in this case, I'm going to use a 2-bit counter. Right. So then now you have your output here, so of the counter, and you have your carry, which means you get a 1 signal coming out of this when the value reach 3. You get that? All right. Let's drop that this up. So 1, 2, 3. See this gone green? because that only change when the counter reach 3. It only change from 0 to 1 when the counter get to 3. So then this now, you can set this as a lockout mechanism. So when your counter reach 3 and the value go over, then you want this to go in a lockout. But first thing I go do is add a reset button to carry back the circuit to normal, which should have been. And then I just copy this. And I go connect my reset button to my counter. I go connect my reset button to my flip flop. Yeah. So when the user press reset button, everything go back to 0. Counter gone to 0, flip flop gone to 0. See it? Meaning say you don't have a correct password that go through to as a lock anymore. As you can see also. So I press enter and then I press reset, everything go back to 0. Alright. So depending on where you want with your logic now, for the number of attempts, you go put this in a one gate and call this your where that's now your lockout. Let me look and see for that now. So as you can see where the flip flop connected to what is play again? Yeah. Okay. So this is what we use to carry the lock signal. So IO would I go to my lock, which is no man. IO yeah, it go to lockout too, But the inverted signal from IO. So that means only when the password incorrect and the counter count 3, then it lock you out. How could not take me for the call center? Anyways,
Boy, answer.
if you what?
Mother and call you.
I know my mother.
Inna.
Not anymore. Yeah, dog. So so if you look, me take the carry value from the counter, right? When it reach 3, me take that value here. But instead of using 3 for lockout, because suppose the person enter 2 incorrect password and on the third time them get it correct, it's still a go send an output to me. So that's why I'm using that gate. So if the value of the password is correct coming from the flip flop, right? Then it now go lock you out. Because if the password correct, then this will be green. It's a 1 send. But the NOT gate will go invert send a 0 into the AND gate. Means that the lockout signal will be 0, even though it reached 3. See that? You, may I say if you don't get that? Alright, look. Alright, let me break it. Let me move them 3 something so you can see them. So 1, 2, 3. Move up this stuff, because me already do that. Let me just take all 3 of them. Hold on. Left out. All 3 of them and put them over. So. Alright, so my attempt button I come from the enter button up this, alright? My reset I come from my reset button. So depending on the amount, let me take them button here too. Come over. So these are the whole lockout mechanism of the take this too. Alright. So next this now. See if we can zoom in further. Alright. So reset. There's 0. So let's say the user enter have the wrong password. 1, 2, 3. You notice what go green? The lockout signal. The user enter 3 incorrect password. But what you want to happen is that even if the user enter 2 incorrect password and enter the correct password on the last try, you don't want it to lock out because it recognizes your 3 tries, right? And that did happen over there. So what
Mikey,
yo,
the IO, where IO come from?
IO come from the flip flop, which are the password. It just tell you if it will be on or off signal. That's how I use IO. Right. So now me have to use something else because you know one that go directly to the LED.
All right, cool.
So what I did is if I have my output coming from the flip flop, which is the correct password, right? The person press the enter button on the correct password, go through the flip flop. So that is IO. If IO is correct, then no matter how many tries they are so, it's not supposed to lock you out. As you can see, one not gate there. So if you have a 1, then you will get a 0 coming out into the AND gate if the password correct. So even if carry, which is my output from a counter, when we reach 3 tries, is saying 1, is saying 1 because you reach 3, it now go lock you out because this would have invert if the password correct. So right now the password incorrect. So let me put in the correct password on the 3rd try and show you what happened. So let me change it. 1010, right? So looking here, so now, hold on. So me press enter. As you can see, the inverted signal go into the lockout mechanism, right? So because the password correct, it will go send a 0 to lockout. Means say it can't lock me out because the password correct. But if me enter 2 incorrect password and then me enter the correct password, you notice that me get a 1 value coming from the counter because it recognizes say reach 3 attempts. But instead of going directly to lockout, may use a AND gate with the inverted password signal. So if the password correct, then you get a 0 going into the AND gate, and because a 1 and a 1 alone give you a 1 for AND, then it don't lock out. And then me take this lockout signal now for put here so for open the gate. So if lockout is activated, right? 1, 2, 3. You are going to get a NOT signal here, so which invert the lockout signal going into the AND gate for the lock. So if me have a 1 here for lockout, no matter how much put in the correct password and press enter. If this hold on. So alright. 1011. 1, 2, 3. Lockout.
No, go in.
Why the fuck it going at that? No one know. It never did that work like that earlier, so I don't know how me change. Probably when me that show no something, me change something. No, so let me go over it. So I have eh? Me know man, me know. This I old one. Oh fuck, this I old one.
Right here, free. Why?
Hey, boy.
My boy, Mikey, stop playing with the girl, Mikey.
No, Mikey, I chop right now. Mikey, the boy can't tell me nothing, boy, Mikey. Then move.
Anyways.
Oh, monkey silence. How am I going for monkey?
I want to sleep, brother.
Why much full, man?
Hey, man, I already a party now, keep on enjoy me. So, me have enough.
So break up the makeup, but we try. Oh, man.
Perry IO.
Mikey, so where the Mikey, where the girl on Mikey? Where the girl? Where girl with Mikey?
If I
I
don't know
think,
my
no,
Mikey,
I think I find a problem.
I think they got people that Mikey and left person.
So that is so
Me know why Mikey.
eh.
Me know
Mikey,
why.
Mikey. You can't sink the thing too deep on them, the Mikey. Chip brain, you know.
Because you answer man girl message brother. Are you?
What? Where that go?
When I
Ah,
first
ah, ah,
recording,
ah, ah, ah,
brother.
ah. All right, focus.
Yo, Guardian, post your recording by YouTube, brother, so we can watch it.
Yo,
Yo, I like that too.
Yeah, just put it by
What?
your YouTube channel. Your YouTube channel?
dog, something alright so. Because if you count the count 3 times, me get a lockout. Hold on, reset. 1, 2, 3. Right? Me get lockout. So what the fuck my lock a change when me put in the card password?
So you mean to tell me say me I cause all of this?
What could I cause all of this?
Chadwick, freaky.
Yeah, leave it alone, Eric. One boy, man, say leave it alone. Focus, focus.
Password. Correct password going. Hold on. What is something I for? Okay, so. Okay. I know that. When me reach. Eh? No man, it look like me never check that then. Yeah, but me never try this.
You never try this. Never try third attempt.
Never try this for real.
You see me? That was new. But we don't need that now, brother. Still, you see me? We don't need that now.
Yeah,
That's
dog,
where
cause
we
him
can
not
we
go
can
check that.
we can work with the basics, dog. I like him on
No,
a
but
be
it don't make no sense. It don't make no sense if you put in three correct incorrect attempt and then put in the next attempt, it go through. And that me I try to figure out which gate.
All right, limit, Mikey. Drop a limit lower.
No, it limit there are three man, that correct. I wonder if I comparator me did want. Oh, fuck. Comparator, alright. Let me show you what I want comparator. A comparator you can use to compare values. So you have two input which would be probably your your output from this and you'd have put one constant and say 3. So if the counter count 3 and the value where you have here as your second input would be 3, then you go get one high signal at the equal sign. If it greater than, then you get a high signal at a greater than sign. If it less than, then you get a less than sign. High. That's what a comparator is. Um, that's why I never use it, but me just a show no what I for. But something alright. I think I flip flop supposed to. Alright, me know what to do.
Mikey.
Yo,
So for your lock system, you use one X get, dog. If me
no
enter,
man, no man. Hold on, let me
if
show
me
you.
enter, if
No
me
man,
enter like,
right
no,
that's
no,
me.
it's not. It's not, man. So if me enter like P2 and P4 and left P3 and P1, still have open. Guys, no, but look at now. If you look on PC2, you can say the input them at 2. Yeah. So if you enter, yeah, yeah, yeah. Yeah.
Me know,
Oh.
me know.
Oh. Mm-hmm. Ah, bro.
I don't think it's a hand gate more want about one gate of come here, sir. Yes, sir. Yeah. I know what hand gate I go there now. Me I wonder if it's a X or me I gonna need. I don't me I do. I go and test and me get it one. So me get a one when that a one. But if me enter. Alright, so let me try now. So reset. 1, 2, 3 incorrect. But you know want that. No, me know if it do. Me can invert the signal from the carry. Yeah, me can use a hand gate. But me have to go put a nut on the carry signal. God, me need to submit this for us then. 1, 2, 3, lockout. Put in the correct password. Still lock. And if me put in the correct password, it work. Reset. Wrong password 2 time. 1, 2. Correct password. Ah, right. Me know. The lockout because me get the 3 tries. Yeah, but the password, right? Exactly.
But then the three
Oh.
tries they can't do no more.
Eh?
When I say, but the attempt can only do 3 times, brother.
All right.
It's not right because
That is what. You know. All right. Memory resets. What mode I want? No, you can't. You know what? You know what? If auto resets, you reset to the act. You can do something like that, but you're in up in a problem because let's say me no want to close the locket and me enter correct password that automatically send a reset to this. You can, you can. Well, you can. Here we would have to do for do that. You know, use a OR gate and the correct password for the reset. Yeah. So right. So Mm.
I have I have to reset it. So after I reach 3 attempt, you can't put in no more until I reset it. That if you do. Yeah.
Yeah, that's right. Yeah, that's my problem. No, if it correct, it's
Yeah.
supposed to
Once
stop
you
you
reach
from
three
enter more
attempt.
password.
Mikey, are you set it the way then, Mikey?
Yeah,
Are you set it like if you third attempt correct, you can go in. Are you set it so? But no, so another thing it say.
me know say something
Yeah.
missing, which should have be if it when it reach three, it's not supposed to lock you out.
You
Not
can't
gonna
put
lie.
in no more.
Right, but my problem now in a chat is that when me reach three, even if me put in two incorrect password and then put in a correct password, it lock me out. One, two, three. It still lock out, but the password correct. Right.
Reset it and put in the correct one now. And see what happen.
Reset it. Yeah,
Yeah,
it'll
reset
go
it.
through. It'll go through. And it stop you from enter more password once you enter correct password. And then reset. But when I
Reset
say
it
this
again.
chat, look, if I put this are my problem. If I put in two correct password and then I put in the incorrect password, it lock me out. You see me? Exactly. Yeah, but other this high problem. Because no, Nadil. Let me tell you why that could work. Because let's say somebody just a try to figure out your password and then put in it, and when it come up incorrect, then it reset again and blah blah blah. Yeah, it reset the contact. It's not necessary. You can put it there, but it's not necessary.
Nice, nice, nice.
Oh, me see where you were saying no, but I know they say you want and a reset button you want it. Oh man, no me I say I know where you have reset in a counter you want it, yes so. Mm-hmm. But you want the counter to actually count three. Mm. No, I just say you want it yes or no deal. Where you have it carry. Instead of going directly to carry, would have one signal where would that be the correct password, which is IO. I go in our AND gate. But even if you use this neither, that means I probably would need all of this out here. So what we can do is take this and this, go in our AND gate. Oops. And our AND gate is our AND gate. So the two of them matching up go through. So let me see now. Shit. Oh my god. Yeah, when the two of them matching up, we go through. So one, two, change this. One. It work. See that? Mm-hmm. No, it can't now go. No, you don't want to can't go back until you press reset. But it work now. One, two, three. So, alright, see three different something here where you're supposed to get. You put in an incorrect password three times, but me lock out. Me not get, me get lock out? Yeah, it lock out, but me need to change something then. No man, yeah man, me need to change the color for lock out. That matter. Because it gone red and me never remember say I read it go. When I want no color when lockout off.
You can there. We not hide nothing, bro.
Yeah,
Send it.
I
Send
can send
anybody
them a
want.
link.
Yeah man,
Anybody
yeah man.
want to see it. We not hide.
Alright,
Send to
see
anybody.
we just figure out something like that. So one, two, three incorrect password, me lockout go on. But dog, me have a problem, me lockout always on. You know see that? Hey, me just reset it. Yes indeed. Alright. Let me show you what I got now. You see because carry inverted, I probably not have to invert this. Remember say carry inverted through non-gate, you know. So I probably can get rid of this. Because if your password correct, then carry if your password correct, and it counter there three, then carry I go be zero. So this I go flip. So let me see now. So correct password. Fuck. Yeah, you're right. It's supposed to lock you from but me get lock. Oh, if carry and IO correct, then we want a non-gate. Want a non-gate. How we going now? Oh no, that the whole circuit I get fucked now. Yeah, I forget the logic side problem, dog. Let me see. So if carry and IO correct, then lockout can go on.
Yo, you will start from scratch, dog. Believe.
Oh man, you don't have to start from scratch, man. It good. So reset. So me lock, yeah, me know say on. Um, so me want the opposite of a what me want that's one. That means I know this me want then. So if IO and carry are the same, then it can reset. So me lock. Correct password, that correct. You lock out, cause you're not supposed to can enter. Wait, one. Why my counter go up two times all ago? Oh, me say I want him, dog. No man. Okay. Go back to him. Me go all the way back. Cause something go wrong. And if me delete something or something, cause I swear this that work out there. Alright, let me see where the problem was. So correct password, me get locked out, so me can't enter no more password. Reset. Enter incorrect password three times, me get locked out, can't enter no more password. Lock still active, right? Incorrect password two times, correct password on the third attempt. That worked. Yeah. But wait, so what the fuck did wrong a while ago? So what did wrong a while ago? What the fuck? Yo, Come, I swear said that work out there, you know. So me I wonder how would that try a while ago? We try correct password. Correct password and me try enter incorrect password. It's not supposed to change because me get locked out, right? Reset. Put in incorrect password 3 times. That not supposed to work because you get locked out. Reset. Put in incorrect password 2 times. Correct password on a third try. It's not supposed to change nothing. It a work so where the fuck? Yeah. No, as in like when me put one lockout signal here, so if me get the password correct, it not allow the user to enter any more password. See there. So the lock signal when it lock, I show say it open, it lock off the attempt button. Right, right, right. You can't enter anything else. So you can't. So if the lock open, you can't put in a wrong password to lock it, and you can't press enter again to get a lock signal. Right. So that's how it's supposed to work. I'm glad say I understand what going on because it's just to really understand the outputs them at the gate and know where you want here so and know where you need to get over there. So it's straightforward. Alright, so I have my password them or me would have put in. So I have 1 2 3 4 bits. My predefined password which is 1010. I have my enter button and my reset button. So from password one and constant one, it got to the XNOR gate, which only gives you a high output when both inputs are high or both inputs are low. So as you can see, me I get a high here, so when one and one, zero and zero, right? So then combining all four of these password checking mechanisms to see if all 4 bits match to get the correct password. And then from this correct password, we're going to a flip flop. What a flip flop does, it keeps the value until there is a certain change made, which means that my change in this setup is the enter button. So it now go change from zero until I press the enter button, and it now go back to it now go back to one to zero because well I put a lockout to the entry them, right? So after that now before we get to this, my counter from the enter button. So if you notice this, I go show one. So if I press enter, all right, voila. If I press the enter button, you get a high signal here, so and you get a high signal here, so going into your AND gate. Show so you make an attempt, and this attempt now going in a count of say, okay, you make a attempt, you must count 1 time. We make a next attempt, we count 2 times. We make a next attempt, we count 3 times. But you have an output and you have a carry value. So your carry value now, which would be giving you a 1 when you get to 3, which is a maximum value. So it's just like what they are when Sarah say, oh, if you do addition of binary and you add 1 and 1, you carry 1, basically that happen here. So when you reach 3 tries, that would count as a 1 signal for the carry. So now carry now goes into my lockout. Meaning say if me make 3 attempts, then it's supposed to lock me out. But if the password correct, then it's not supposed to lock me out. You see me? Get that? Alright. So then me take the same lockout signal and the correct password signal from here. So as you can see, so password correct and lockout signal inverted. So this going at the AND gate. So if the password is correct, if the password is what did I say? Correct. May I get an inverted lockout signal coming into the lock for sure say okay correct password entered. And the lockout value is 0 because you now get a lockout here. So password correct and your carry is at 1. So you now get nothing. But basically that's the explanation for this. So just if you understand how gates work and put a circuit together how you want it. So as may I show you, this are the password checking mechanism here. So all of this over here. So yeah, watch one answer that. Anyways, all right. So over here, so I'm a lockout and my reset mechanisms. So as you can see, reset connected here. I'm have my reset button. Everything else we see over here, so is a part of the lockout mechanism. So that so I'm gonna move the constant then go over here. So as we did, I suggest so that everything can be organized. So say this is your password check inside. On one side I'll be a lockout side. So password check. Everything up here so the user would have access to. So initially the user can set the predefined password. After that the user can put in the password where they want to enter. So it's either them go enter 1 or 0 here. So and you have your enter button to make an attempt, you have your reset button, and you have your LED them where display the state of the circuit. Isn't me? And then everything over here, so where I see so is like my lockout mechanism. Actually.
You matter how much LED you have? I would say I have 4 LED. I just need 2.
Alright. You don't need all of this. You just need one, which are this. No, you don't need a LED for sure say lockout. You just need a lockout mechanism. Yeah. Yeah, it makes sense to
Yeah,
just
that's
say
what one too. You say use 2.
yeah.
Yeah, attempt there.
Yeah, them they don't necessary. Guys, yeah,
Yeah.
yeah. So when you press reset, it shows say you press a reset button. And when you press enter, it shows say you make an attempt. Like you want to know if your button will work or not. You see me? That me at that.
Oh, yeah.
Yeah. So it's just it's not necessary, but it's like making it more user friendly. Because you know if you put in password and even though you put in the correct password, it now go through. So that's why I put attempt button there for sure say okay, whatever you enter actually I go through the circuit. And the reset button LED did there for sure say when we press reset LED, it will change the state of the circuit. But that's it, dog. So I just for wanna know, try and build something. If you're not running a problem, I'm gonna show up me and my giant mark. Is it me? I deal with something.
I'm a boss. Alright,
Alright. After that, later or tomorrow we can start the CNC if you don't want.
don't worry, never.
Alright. So
Big up yourself, respect.
Respect.
we're
So
gonna
we are doing this. So individually, we are gonna just done this tonight then, and then tomorrow we do the CNC.
yeah
Yeah,
man.
yeah.
So each
Bob.
now una can stay on the meeting and work on it, so if you run that program, I'm gonna show up me and my giant back, you see me?
Oh, yeah.
Who the fuck
Right.
name? Sorry, who name Freaky?
Yo, outside.
You think Obiri, you know, but they must say Obiri Waters right there, so you see me?
Yo. Everything is
Oh,
I'm here
wait.
stage here.
So this new one document?
It's like up on
Eh?
YouTube. You know.
This new one document?
In a group, yeah, you have to set those document. Bomba
There's a
now
game.
there.
There's a game with a good dog. Kill them crazy. Kill them. Kill with a good dog. Ah,
Alright.
boss. You right.
Let me see how much you might say.